So yesterday on Twitter, I saw some people arguing about the performance improvement of the Windows Run Dialog. Now, if you're not familiar with the Windows Run Dialog, it is a dialog that opens up when you press the Windows plus R keyboard shortcut. And it opens up this window down here in the bottom left-hand corner of your screen that says Run. And it has this text box in here where you can type commands. And in fact, you can type commands, you can type a file location, you can even type a website, and it will open these things up. As an example, you can say type Notepad, and it will bring up Notepad for you. So that is the Windows Run Dialog. And in this blog that they released a few days ago, they say the Windows R crowd measures time and irritation, not seconds. So the old Run Dialog had a median time to show of 103 milliseconds. So I'll make this a little bit bigger. So the time to show of 103 milliseconds. So basically the idea is that when you pressed the Windows plus R keyboard shortcut, it would take approximately 103 milliseconds for that program to load and start up and show its window to you. Okay. While the new one currently appears in about 94 milliseconds. So that's approximately a 9 millisecond improvement. So that's good. In fact, they say in practice, the point is not that users will consciously perceive a tenth of a second dialog becoming slightly smaller slightly smaller tenth of a second dialog. The point is Microsoft is talking about the right metric. Run is not a destination app. It is a reflex. The people rely often on launching command, PowerShell, regedit services, and others because the start menu is too slow, too search-driven, or too eager. So for this audience, the cardinal sin is not visual ugliness. It is hesitation. So Windows users have tolerated old dialogues for years because old dialogues tend to be fast, predictable, and pleasantly under-designed, right? So the idea is they made this just a little bit faster because it's more pleasant to use faster things. And so they're doing this just because they want things faster, which is good. The argument on Twitter is that 94 seconds is still quite a long time to wait for such a simple program to start up. If you look at it, let's look at it here. The run window is just a basic window. It has no menus. It has some text under here. It has essentially a text box and 3 buttons. That's it. That's all it has. And all it does is it executes certain programs, and that's essentially it. And so there is an argument between people on Twitter where saying that, like, well, 94 milliseconds is basically instant, right? You don't need to care. I mean, they made it a little bit faster, but nobody is going to tell that you're going to make it a little bit faster. The other crowd says that 94 milliseconds is quite a long time. Especially under game dev, they're able to render an entire world in less than 16 milliseconds most of the time. So why does it take 94 milliseconds to simply open up a very simple window? And so that was essentially the argument. And it made me wonder, well, how long should it take to open up one of these simple windows? So what I did is I ended up writing my own version of the run dialog. So I'm going to move over here and I'll show you that I wrote a couple things here. You can see there's this main.c file. There's this run fill dialog.go. And I'll introduce you to them, and then we'll take a look at how they run. So the main.c file is essentially a C program that uses Win32 to create a window that does this run dialog operation. And I can show that to you real quick. So we'll say main.c. And so you can see I just include a few different libraries here. This first function here is essentially a callback function that's used for the event loop. And so what will happen is every time an event happens, it's passed into this function, and it switches on what type of message is sent to the window. If it's a destroy message, well, then we'll post a quit message, and then we'll exit out of the application. If it's create, which happens at the very beginning of the program, we'll create all the things that we need. So I'm creating a label for some text, the text box, and then the 3 buttons, OK, cancel, and browse. All right. Then, of course, if we have a command action, then what we can do is we can handle the button clicks. And so the button clicks will have the OK button, and then we handle the OK button stuff, which will essentially execute essentially execute what's inside the text button. If we hit the cancel button, we're just quitting out of the application. And if we hit the browse button, we're going to browse through the file system, right? And then, of course, the win main function just initializes the window, creates the window, and then it shows the window. And then at the very end, what I do is I print out a done string. So that way, the idea behind this is that when we load this program, once it shows the window, we're going to print done to standard output, and we'll have another program that's listening for that. And so that program will essentially start up this program and then measure how long it takes until done comes out, right? And so I'll show you my startup program, and this is run fill dialog.go. It's a very simple program. So I create a little buffer. I create a command, which is essentially just running the a.exe file that we created. Create a little output pipe that will read that output. Then we start the program. Or actually, yes, we actually get the start time, and then I start the that command, right? So I'll start that command running that executable, and then we'll read the output of the buffer, right? So when it gets to the point where it prints out done, that's what goes into here. And so basically this line will block until we read that done string. And then once we read that done string, we can get the duration and print the duration. So this is how we're able to run our own dialog and check how long it takes for it to run. So let's go ahead. I've already compiled these programs. So let's go and say run the fill dialog. Or in fact, I can just run this a.exe first, right? So you can see this is what the exe looks like. It looks a lot like the run dialog down here. It's just slightly different. I didn't pay attention to making this very aesthetic, but it has all of the major functionality. So we can do things like browse, and we can say let's browse for all files, and let's open the main.c file. And it will open it in Microsoft Visual Studio. So we can see the C file here. By the way, it's approximately 170 lines. Okay, let's close Visual Studio. So the browse button works. We can use this. We can say open something like Notepad. Click OK, and it opens Notepad just like the other run dialog does. And you can open up anything like this. You can open Task Manager, and it should work. So it opens up the Task Manager. So yes, so this is essentially the other button, of course, is cancel, which will close the dialog. And just like this one. And so this program that I wrote has essentially all the same functionality as the run dialog. So what we're going to do is we're going to test this out. So we're going to, let's take a look at this. Let's clear. And what we're going to do is I'm going to run this filldiag.exe, and that will run the a.exe file and see how long it takes to load. So let's go ahead and do that. Run filldiag, and it opens it up. And notice it took around 21 milliseconds, right? Now that's loading it from disk. And so after this, I assume it should be loaded into the disk cache. So we would expect it to run perhaps a little bit faster the next time. And so that's around 20 milliseconds, 19 milliseconds. Okay, so now that it's cached, it gets, maybe around 20 milliseconds. So that's basically how long it takes to run one of these things. Approximately 20 milliseconds. So if we look at that compared to the time that they published, 94 milliseconds divided by 20 milliseconds, my program is approximately 4.7 times faster. And so the interesting thing about this is that, let's run this. Let's do browse, all files. Let's see, where is it? Main.c will open. So what's interesting about this is that it took me maybe an afternoon to write this program. It's only 170 lines. In fact, it's less than that because we've got some comments and we've got some empty lines. So maybe it's around 160 or so. But I basically have almost all the functionality of the run dialog in around 160 lines. I wrote it in an afternoon, and it's 4.7 times, and it has 4.7 times less latency than the Windows Run Dialog. And the thing is, this really shouldn't be possible. Microsoft is a multi-trillion-dollar company, and I'm just a guy who wrote this in my spare time in an afternoon. And it shouldn't be possible for me to outprogram the entire multi-trillion-dollar company by myself and write something that's almost 5 times faster. And so I think what's happening with this argument is that some people think the argument is about the program itself, right? Maybe it's this program, and it doesn't really matter that it's a little bit, it doesn't matter that it's kind of slow to start up. Now, the thing is like if I start, say, the Windows version and then my version, I can kind of tell a difference, barely. And you probably can't tell a difference at all because this is recorded at 30 frames per second. But basically, my program will open up in about 20 milliseconds. And if you think about it, a single frame at 60 frames per second is 16 and 2/3 milliseconds. So if we say 20 divided by 16.666, then my program opens up in about, actually, can I make this bigger? So my program opens up in around in basically 2 frames, right? It takes less than 2 frames, but if you think about it, on the second frame, it'll show. Microsoft's version is 94 milliseconds divided by 16.6. It shows up in around 6 frames, right? So, that's a tiny difference, right? And so it doesn't, for this particular program, is somebody really going to notice? Probably not. If they wrote this program as fast as it could be, and I don't see how anyone could write it much faster than what I did, they're not going to really notice. So some people are arguing, hey, this doesn't matter. But I think what the other side is trying to argue is that the point is not about a particular program. The point is more about the culture of the company. Does the company care about excellence? Does the company care about creating things that are awesome? And do the people strive to always make something better? Do they strive to increase their skill and their knowledge and the experience of the users? Now, it's good that they're actually making the dialogue a little bit faster. They made it 9 milliseconds faster. But you have to wonder, what the heck is the program doing to waste an extra, what was it? Let's see, actually, let's open this up. 94 minus, let's say, 20. So how are they possibly wasting 74 milliseconds? What is the program doing? And it reflects on the culture that Microsoft has, right? And Casey Muratori is a kind of a famous programmer who has talked about this before. He's gotten into arguments with some people at Microsoft about their terminal. So when they were first released their terminal, it was fairly slow to render text. And he got into an argument, and apparently someone at Microsoft said that it would take, a PhD dissertation to figure out how to render text fast. And so Casey went and wrote a terminal in his spare time, I think over a weekend or maybe a couple weekends, and was able to write one that was ridiculously faster. And so he said that, like, it doesn't take a PhD dissertation. You just have to do the basic minimum, right? You just have to write code that is not pessimistic. And he also ran into another thing like this. He showed a video that he took of him running Microsoft Visual Studio. I think Microsoft Visual Studio 2003. And this was on a machine way back then. I think it was somewhere around 2003, 2005, which meant he was running a single core 32-bit machine that probably had that didn't have an SSD, right? And so his video that he showed him running Visual Studio, debugging a program, and the watch window could update instantaneously, right? He could step through the program, and the watch window, which was looking at different variables, could update instantaneously. And then he showed his current version of Visual Studio that runs on a multi-core machine at 5 gigahertz at 64 bits, and the watch window just couldn't update, right, instantaneously. So despite the computers getting maybe 100 times faster since then, maybe 50 times faster, the software got so much slower that it couldn't even do something that it did 23 years ago. And so that's kind of where the complaint is coming from. The complaint is that we should be better in performance than we were 23 years ago, right? Software should actually get better. We have all this time and we have all these new tools. We should be creating things that are better, not slower. In this case, with this particular program of the Run Dialog, it got a little bit better, but people were wondering, how is it not as fast as it should be? This program has existed for decades, and it's the simplest program that you could possibly write on Windows. Why is it taking an extra 74 milliseconds? How have we not solved this by then? So that's essentially the argument that is happening. And I think one side is missing it because they're focusing just on this program. But the true argument is that we want to live in a world where it is pleasant to live there. We want to live in a high-trust society. And the way that you do that is when everyone is trying to do their best, when they're trying to always make something better and make it with excellence and always improve themselves. If you have a society where lots of people are doing this, then you live in a better world, right? That's how you do it. And if you don't do that, if you're just trying to squeeze every penny out of somebody, or just trying to get your next promotion, and you don't care about your product, and you don't care about your skill, and you don't care about quality, and you don't care about speed, well, you get exactly what most of the rest of society is experiencing right now. It's basically enshittification of everything. And, that's unpleasant. It actually makes it, the world a less pleasant place to live. So when people are complaining about this, it's not because they're trying to make people feel bad. It's they're trying to provide motivation and awareness for focusing on things and actually making things better. So that's basically all I wanted to talk about with this. And thanks for listening, and till next time.